Right, so let's do a few more problems. Number 6. John bought a machine to make fresh juice. He has 5 different fruits: strawberries, oranges, apples, pineapples, and lemons. Okay. No, that doesn't spell anything. Okay, so he must choose 3 fruits to mix it and blend it. So there are 5 choices to choose from for the first fruit. Let's say strawberries, 5. And if you choose strawberry in the first fruit, I don't think you want to choose strawberry for the second fruit. So now you only have 4 choices and then you have 3 choices. But are we done? No, why not? Because if you chose, let's say, strawberry, oranges, and apples, and for another drink, you choose oranges, strawberries, and apples. When you mix it together in a blender, it's the same drink. It's the same exact thing, right? So when you switch the letters around, it's the same thing. Then it's a combination. It's out of 5 different fruits, you're gonna choose 3 to mix it in the blender. And if you switch the fruits around, it's the same drink. So that's the difference between permutation. Permutation, you just go 5 times 4 times 3 and you're done. But for our combination, you switch it, it's the same thing. So you count it too many times. So you need to make the number smaller by doing 3 factorial. So if you do that, you're gonna get 10. There's only 10 different kinds of drinks you could make. Okay, I could make a list of them all, but you don't want me to. So there are 10 different kinds of drinks. Okay. But if it was, permutation, if the order matters, then it would have been 60 different drinks. Okay. Like if the strawberry stays on top and orange is in the middle and then apples in the bottom, and if you put orange on top and strawberry in the middle, it's a different color combination, that kind of stuff, there would have been 60 different drinks. But if you mix it all together and blend it all together, there's only 10 different kind of drinks you could make. That's the difference. So if you switch the letters around and it's the same drink, then order does not matter. Whether you do first one, second one, doesn't matter. So it's a combination. But number 7, this time order matters. Okay, so there's a chairman and a co-chairman. So there's 2 people to choose from, and there are 10 people to total. So for chairman, you have 10 choices, and for co-chairman, you have 9 choices. And then do we divide? No. So let's say Adam and Bob was chosen as chairman and co-chairman, and then Bob and Adam. Well, these are different situations. They're not the same. Adam is the chairman in the first situation, and Bob is the chairman in the second situation. So if the order matters, like who's first matters, then you don't divide. It's a permutation. Okay, so you just go 10 out of 10 people. You're gonna choose 2 people, chairman and a co-chairman. And for permutation, you only do 10 times 9. The a factorial gets canceled out. So there are 2 spaces to fill, and we don't divide. We don't do a fraction divided by 2 factorial. So there are 90 different ways to pick chairman or co-chairman in a 10 people group. But number 8, there are 10 people in a room, and you want to take pictures of everyone who do the handshake. I think we have handshake problem before. So you need to choose Adam and shaking hands with Bob. Okay, and then Adam and Carlos and Adam and David, it keeps going. But if you switch, if Bob shakes hands with Adam, well, they already did. It's the same handshake. Either whether Adam shakes hands with Bob or Bob shakes hands with Adam, it's the same thing. So in that case, we don't just go 10 times 9, because if these are same, the order doesn't matter who comes first when they're shaking hands, or it's the same 2 people in the picture if they're taking pictures of it, right? Adam and Bob and Adam, they're the same 2 pictures. You already took pictures of those 2, so you don't need another one. So you need to do a 10 combination too. So you don't have to have 90 pictures. It's actually divided because you already took Adam and Bob. So now you're going to take Bob and Adam. No, we're not going to do that. So you take less pictures. 2 factorial, which happens to be 2 times 1. So you only take 45 pictures. Got it. So that's the difference. Permutation, if you switch it, order matters. So if you switch it, it's a 2 different situation. Like if you're, opening a safe and then you switch the numbers, it's not going to open because it's a different combination. It's actually the word permutation. And then combination, you just want like 2 things or 3 things or 5 things at a time. Then it doesn't matter which order you take things, then it's a combination. Okay. I don't know, maybe I'll just do a couple more. 14, 15, 16 is it's just a review. It's just how many different ways, which is still multiplying, permutation still. Okay. But yikes. So number 12, let's do that one. So there are 112 people. Wow. 112 people, that's a weird number. They bought raffle tickets. Okay, and I'm thinking it's a separate people, not same person buying 112 different tickets. So 112 different people bought raffle tickets and they won 3 prizes. Exactly the same prizes. That's kind of important because it doesn't matter who gets it first. The order does not matter because if Adam, Bob, and Carlos gets the prize, well, that's the same thing as Bob, Adam, and Carlos getting the prize, or Carlos, Adam, and Bob getting the prize, or Bob, Carlos, and Adam getting the prize, or you know what I mean. Okay, so it doesn't matter because it's the same prize. Okay, if it's 3 different prizes, like somebody wins the TV, somebody wins the car, somebody wins the, I don't know, a new house, then I rather win the new house, right? So the order matters, but it's the same price. Whether you get it first or get it second or get it third, it's the same, same refrigerator that we're winning. Well, then it doesn't matter when you win it, right? So these are all same kind of situation. Oops. Okay. Oh, I'm in the wrong problem. Okay, these are all same situations. So if they're the same, then you counted too much, which means you need to divide. So that's a combination method. So 112, we're gonna choose 3 winners. So that's the formula. Out of 112, we're gonna choose 3 winners. So we practiced this yesterday, but I'm just gonna write it down. So 112 times 111 times 110, 1 less each time, and then it keeps going with 109, 10 whatever, and then but it gets canceled out by 112 minus 3 factorial. So these are 3 numbers that survives after you cancel out the 109 factorial. And then in the bottom you still have 3 times 2 times 1, 3 factorial. You gotta see there are 6 of these. 3 factorial means 6. So I guess ABC, and there's a ACB, BAC, BCA, CAB, CBA. So these are 6 different ways that Adam, Bob, and Carlos can win. So these are all same situations. So there's 6 of them. Should count as only 1 of them. So we need to divide it by 6. I know you don't get what I mean, but just that's what it is. So combination, just remember this formula. Combination means you need to do the permutation thing and then divide it by the second number 3 factorial. So 112 times 111 times 110 divided by 6 is, I get 227,920 different ways. Because 112 is such a big number, you get big answer. Okay, alright, so hope that helps.